I guess first of all, Peter, do you know everyone here? Maybe not. We could do a quick round of intros.
I had a brief introduction with Joe, and I know Lindsay and Doug and Dominic.
Perfect.
So it's just Dieter.
Devin and Tivo are also here now.
Peter, do you want to start off with
Oh yeah, and I know Thibaut. I don't know Devin.
Yeah, hi Peter. So I'm Devin. I've worked for the UBC GIF group for the last 6 years. I did a master's and with Doug, and for the last 3 years I've been doing some development with GIF tools. I've got my hands in SimPEG, doing a lot of documentation and support for the Fortran codes. So I kind of have my hand in a lot of different things. Yeah, that's more or less my story. I'm still working at UBC under Doug.
and Dieter?
Yeah, I can go on. I'm Dieter. I'm currently at TU Delft in the Netherlands. I think I got involved in the whole SimPEG group when Doug and Lindsay were in Mexico in 2016, 17, something like this. Because I lived in Mexico for a while, working there for the Mexican Petroleum Institute, and now here at Delft, mainly in electromagnetic modeling, with some of my own packages and more with SimPEG codes as well. So that's why the meetings are now in your morning, so I can join in my evening.
Okay, good to meet you both.
Peter, do you want to start us off just kind of with a bit of intro and let everyone hear, your interests and yeah.
Sure. Yeah, that's a good plan. Yeah. So since 2009, I've been working with Colin Farquharson at Memorial University, and through those years, we've developed quite a large suite of Fortran code, which has some parallels with what's being done in some of the Python packages. So we felt that there's definitely some lessons we could learn, and I would also like to provide any opportunities to help in any way I can. That's basically it, but don't really have the first clue about where to start with that. Not a Python person, but there's code that could be connected. So I wanted to start sort of feeling out how that could be done.
Sure.
Do you want to, Peter, because I know, but I don't think everybody knows, like what are kind of meshes you're using, what kind of numerical problems you're looking at, that kind of stuff?
Sure, yeah, that's a good idea. So right now we have support for rectilinear meshes, but most of the focus has been on unstructured meshes in 2D or 3D, so triangles or tetrahedra. And then as far as the types of data we can support, magnetics, gravity gradiometry. We've done some of the simpler seismic, so just a fast marching solution to do first arrival travel times. We have uography capabilities. Oh, what else do we have in there? Electromagnetics, controlled source electromagnetics. We haven't, the only thing really missing is any of the electrical methods. We have something for MT. And then as far as the inverse problem is concerned, a whole bunch of different regularization options, so not just L2, but also a couple of fundamentally different ways to solve the inverse problem. So, or three, I suppose. One in the kind of standard voxel approach, where you have each cell has continuous physical properties in it. We can also do the same sort of thing, but have discrete property values. So more of like a rock type inversion. And then we also have this other approach where we're working with a surfaces. So it's a surface-based model, and those surfaces represent the contacts between two discrete rock units, and we move the contacts in space. So the parameters of the inversion are the 3D spatial coordinates of the vertices in those triangles that make up those surfaces. So I think that covers basically everything we can do and have been trying to do. Some of it, of course, is a lot more mature than other bits.
What's the difference, Peter, between the surface inversion and the geological model inversions? The one is not discretized at all, only by its boundaries. Is that what's the difference?
Yeah, the geological, like lithological inversion type thing is just you have a mesh and it stays where it is, but you're just putting in lithology IDs, which are integer values, rather than some continuous physical properties. So, and then those lithologies get connected to the physical properties through some mapping. Yeah, and then there's a whole bunch of joint inversion options in there too. So looked at a whole bunch of different types of coupling options for just general inverse joint inverse problems.
And the code is open source, or is it like in a consortium, or is it in?
The code is neither. Like, right now we are just trying to think about the best options for getting it out into the world. I suspect that parts of it will and can become open source. We just need to kind of decide how to make those decisions.
Fair enough.
I gather there's still the question of how to sell open source to industry, but maybe some of those questions are being answered, and so once I get a better feel for that, I'll be able to move forward. But yeah, there's certainly a drive for me anyway to help the open source community with the code in ways that I feel comfortable with.
It is the same question that everybody's asking: how to make money off the open source.
Yeah. What would be a helpful overview, or are there specific questions you have in mind right now, or just kind of getting plugged in? Because we could sort of spend some time either talking a bit about discretize, like where the meshing is, or go through a few examples.
Yeah, well, it's a bit needs-based for me. I mean, Doug has been encouraging me to get involved with the SimPEG group for a long time, and I haven't, because I haven't really felt the need. But I would like to start working with electrical data, DC resistivity, and whatnot. And I talked with Florian in the PyGamely group, and he said they don't really have a great set of potential field forward solvers for unstructured meshes. And the SimPEG group has mentioned that you'd like to start having support for unstructured meshes. So I feel like it's time to connect everyone. So those are the three goals driving my interaction with you. And yeah, Lindsay and I talked a bit about maybe what the first steps might be, and we thought maybe just the first step is something simple, like let's try and get SimPEG to the point where it can read an unstructured mesh from a file, something that's created elsewhere, and then interacts with my code to calculate a linear forward operator, and then just uses that to calculate some data, and then we visualize that. And that seemed like a simple, small first step goal that would at least force us to start asking some of the bigger questions.
Hmm. Yeah, I know I've certainly been interested in trying to get the unstructured tetrahedral meshes into SimPEG, into the discretized package, so we could at least use them if we have them.
Joe, what do you think is a good first step for sketching that out? I mean, because we don't have that support right now. Do you think that,
Right.
Yeah, do you think maybe starting from an example from PyGimli, or do you think we should basically just sketch out the architecture first? I mean, because most of the like properties and methods, what we need is probably reasonably well defined.
Yeah, I think we should just go through and identify, okay, what we need to get, what we need to be able to have from this mesh. So like we need to have things like a phase divergence operator, like the things that we need from the mesh, right? For it to be able to work well with the discretized ecosystem. At least, yes, like just list the things that we need from it. And then we can see where we can pull things in from other sources to be able to construct those without having to do them ourselves too much.
Yeah.
And if we do, it's not the worst ever, because it's understood how to construct those meshes generally.
Well, you're using TEDGen, right, Peter, to do it?
Yeah, that's right. Yeah.
And so that's what PyVista is already using. So I'm sure they already figured out the hookup, the hooks.
Yeah, and I'm not really super concerned about generating the mesh. I guess I meant like concerned about just being able to use it once it's generated. We need the properties we need to be able to have on it.
Yeah. And so for a first problem, because that even then maybe prioritizes which operators we implement first, are you thinking potential fields then? Or DC resistivity? Because we could do either as an initial focus. It doesn't really matter.
Yeah, I think if we start with potential fields, I'm just trying to pick the simplest, fastest thing. Just
Do you have the do you have like the forward operators already that work on tetrahedrals and triangles?
Yeah. So it's all Fortran code that calculates all that. So
Okay.
you know, I would just need to know the observation locations, and then
Right.
I could crank through that. Yeah.
That's definitely something we don't have in there right now. We're just everything in the potential fields module, at least the analytic part of it, only assumes things are rectangular in general, like in shape.
Did you ever look at kind of that dual problem where basically, everything is tensor mesh, but now you got topography, so it's really nice to have triangular tetrahedral elements to model that. So you basically are kind of having a little bit of both meshes?
Yeah, so that's a bit like the, what is it called? The cut mesh approach that is used in something.
Oh, Rob, I think was doing that, right? Rob Ellis?
Yeah. Yeah, so sure, that we've never looked at that. I think ultimately we wanted to work with just purely unstructured meshes because they were just so generally flexible, because something that we have been doing a lot is getting geological models from people to use as constraints, and once you have those, it really just makes sense to have a fully unstructured tetrahedral volume.
Okay.
Yeah.
Okay, well, maybe we can get updates from other folks, and then if there's other questions that come up, we can go through there. Maybe, Dom, would you mind kicking us off? You've been organizing lots of things with the SEG and kind of making things happen there. Yeah, I don't know if you have other things.
Yeah, that was my great pain, great pain of last week. Basically, just to get everybody up to speed, is that I for sure not going to go to Texas in October. Dequan is not going. Basically, no one here is going to SCG this year, as far as I know. And then their hybrid approach seemed super annoying. Is that basically you cannot have an online presentation. You can only pre-record your video, and at the end of it, you can ask questions by calling in, basically with a phone, which is insane. But anyway, so in the end, I kind of accepted. Okay, we'll do it. We'll do the video. Basically, the idea would be that we'll just parse it in like three segments. Lindsay, if you would like to do the first one, that'd be great.
Sure.
Just do a general intro, right? Sorry, you were saying?
Yeah, no, I just said sure.
Yeah. Like initially you were proposing to use a transform, which would have been great, but it's SCG. They want to have full copyright on everything. They don't want to reuse anything that's coming from the outside. So we need to redo something for them, basically, if you want to do it.
Change the color.
Yeah, whatever. Yeah, we just change the background and then splice it in or something. So Jeja is also doing his machine learning workshop the day before, and they're also going to do the pre-recorded videos. So what we thought we could do by email is that we do basically one long video which has 3 segments in it, but then we have like a 15 or 20 minutes like still frame where nothing is happening, and then we let people just get out of SCG and bring them to either a Zoom call or a chat session on Slack, so that people can ask questions and you can interact with them. And then the video is going to keep rolling until the next thing comes on. And then we're going to, do this 3 times, basically. I don't know what people's ideas are about this, but that's kind of what we accepted that as SimPEG we would be doing, instead of pulling the plug completely.
Yeah, and we could even do like what Transform did with basically floating like a Slack link on all the slides or on the entire presentation, and just have that there and sort of be in and be able to answer questions and things like that. Because yeah, without the interaction, you're just watching a recorded tutorial.
Yeah, it's not really a workshop to me. This is more like basically a YouTube video, which we shouldn't have to pay SCG to present. But the thing is that what made me change my mind is that people are already registered for it. They already paid for the workshop. So I was like, well, okay, so if we have people that are interested in SimPEG enough to pay for it, we should probably do something. So let's do it. But it's just going to be a little bit different than what we're used to.
Yeah. So the idea is that you're giving a presentation that people can be watching, and then they'd have a Slack channel open or a Zoom. They'd actually be they'd be sitting at their screen, and they could be watching. They could be watching the presentation and have a Zoom. Can you have 2 of those things going at the same time? Or you need.
Yeah, I don't see why not, because technically what's going to come out of the SCG is only going to be like a sound feed. So as long as you don't have to share a mic or camera, you could technically have the YouTube or whatever platform they're gonna use, and then just have a Zoom going on at the same time. I'm hoping so, because well, otherwise it's just going to be a video. What can I say? That's all they let us. Yep.
At least can they be able to see the presenters and kind of interact a little bit more intimately as you're asking a question. Yeah,
because like learning about SimPEG and how to use it if you're actually not doing it. And I'm sure SCG is not going to let people like rewatch the video afterwards, because it's all going to be like under lockdown, right? So it's a little bit useless in my mind to do that kind of exercise. But whatever. We have to do it now. I committed.
We can plan that out too and give like, I mean, because even just kind of giving an overview, it's not hands-on, but at least let people know where to go to find things and how to reach us and stuff like that.
Yeah, exactly. It's like an advertisement, right? We're basically doing a spot and then see what comes out after.
Yeah. Thanks, John. Are there any other things you wanted to share? I'm sure that consumed more of your week than.
Well, maybe on the general theme. So thank you for accepting. You'll be giving basically a shortened version of the Transform 2020 for like framework, right? General framework.
Sure. Just let me know like how long you would like that to be, and we can coordinate on like what that should look like. But
Well, yeah, you have a 3.5 hour slot, right? So
okay.
if we do 3 segments of 45, you just prepare for 45 minutes type
Sure.
of thing. Yeah.
Happy to.
That's long enough that people are not like tuning out and have question periods in between. And then I'll be focusing on the because the team is taking open source, right? So I'll be focusing on maybe a little bit of 2D data processing with scikit-learn, and then the apps that I'm working on at Mira for the potential fields and the EM1D. So have people run those apps, because I can work on I can put time on this and charge it to Mira. So that's a double whammy for me. I don't have to work over the weekend. I can just do it there. That's it.
Cool. Thanks, Tom. Joe, do you have updates?
Sure. So I worked on over the last week about getting volume averaging working for tree meshes. So I already had it for tensor meshes going on that branch, and I finished it up for the tree meshes. It could definitely use a little bit of test driving. The only bit I've done with it is the simple examples I've written. Like it seems like it's a pretty robust example in that it creates 2 random meshes and interpolates between them. So yeah, like at least it'll do that differently. And they're different. They have the different bases. They have different everything. So they just have the same extent. So it should be pretty robust to that test.
I'm going to take a look, man, this weekend. Did you see we can do both, right? Tensor to arc tree and arc tree to tensor, or just one way?
Both ways.
Both ways, good.
Yep, and then tree to tree. So all of them. What else?
So Joe, how do you test? Are you actually like running a forward simulation on something and seeing if you can get the same results out? Or
so what I do, just to double check that the volume averaging is doing the job correctly, you can double check if the meshes are on the same extent. If you volume average one to the other, you can multiply the first by the cell volumes and sum them up and see if that's the same as the second times the cell volumes summed up.
Preservation of mass.
Yeah.
Exactly.
Yeah.
Good.
Just if the mass is the same on the 2 meshes, then the volume averaging did the same. Like did its operation correctly. So basically test it. There's 3 ways that I wrote the function. You can call it in 3 ways. You can either call it between 2 meshes and it'll give you back the averaging matrix that does the operation. If you call it with the 2 meshes and then an input model, it'll just do it without forming the matrix. And then you can supply an output value for it. So if you want to use something that's pre-allocated, it'll use that and fill that with the output and then return it again. So 3 different ways of calling it. It's examples. The test all 3 of them at the same time. So it's like I said, it seems pretty robust. I think the tests are doing a good job, but it could use a little bit of test driving to see how fast if there's any spots that might need a little bit of attention and improvement, although I'm not really quite sure where it would go right now. But that's mostly it. Just make sure it works for your examples.
Daniel's here.
Yep.
Hey, Joe, have you thought about like, let's say you got a topography. So now,
So I did think about that a little bit, and right now I didn't put it in. However, if you do it on the input mesh, right? If you want to remove cells from the input mesh, what you can do is just remove columns of the matrix and then rescale it. So everything's all the columns sum to 1. Or all the rows sum to 1 if you want to redo it that way. That'd be the easiest way. And then obviously if you have topography in the output, just remove the rows and it doesn't matter.
Yeah, think about that.
You're thinking about that stuff.
Does the transpose operation works, Joe? What happened with the transpose operation? You just put zeros in the other mesh if you're outside, or if you use a transpose of the interpolation matrix.
So, I mean, if you have the interpolation matrix, it returns a sparse matrix. So it's just that so if you're interpolating from a mesh and you want to like discard the value of cells that are in it, and you don't want them to come, like if what he's talking about, what I understood from previous talks is that you could have, like you don't want to necessarily include the no value of the empty cell. In that case, like I said, it has each row has the contribution of a cell by every value overlapping cell in the input mesh, right? So what you do is then if you want to discard a cell in the input mesh, you remove that column and then you would rescale all of the rows to sum to 1 again, because that would mean that, okay, you only have these 3 things contributing to the volume instead of like 4 in a 2D sense.
Or Sagi, I think what we would do is just do a mapping, just do the active map after you do the interpolation, and then you slap the active map. So then you remove the error cells after.
Then like the problem is like, let's say you got like 1e-8 for error cell, and you got, I don't know, 1 ohm meter, well, 1 Siemens per meter. Then yeah, it's you may not want to average those points. So yeah, so yeah, I think somehow we need to omit that when we're interpolating. So yeah, what Joe said is making sense to me.
But right now, it just operates between 2 meshes.
Right. And then you generate the sparse matrix that you can move one from the other.
Yeah.
Yeah. So Don, I think you cannot go back because one is like you're sort of upscale, so you cannot go.
It's not a.
But we can have like a transpose. We can have an adjoint.
Yeah, it's not a self-adjoint thing though.
Correct.
Well, we're gonna have all the indices in the matrix, so then we can just clean it up to do what we want, I guess. Like you did all the hard work of figuring out which cells were where and the partial volumes and all that, so you can probably just tweak it.
Yep.
Thanks, Joe. Anything else?
I've been also playing with Azure pipelines on Discretize on my own repository to get it so we could have one spot to do all the testing on all 3 platforms, as well as deploy all of the Windows wheels that get deployed right now, and the source distributions, build the documentation, things like that. You can have it all in one spot, which would be nice. The way I have been testing it was on Discretize. It's okay. I test 3 versions of Python on 3 different operating systems. So there's 9 tests that get run, and they can all run simultaneously. Whatever virtual machine they're using on Azure runs faster than the Travis, so they actually complete faster. And like I said, it's just kind of nice to be able to have it all in one spot. And right now, the app layer only does 1 test at a time, and it does 4 tests, and it takes forever to complete any of them. But I've just been playing with it on my local repository and trying to figure out, make sure we can do everything we need to do. I was also testing it a little bit with SimPEG as well. And like I said, it runs a test generally faster. The install and build time is a lot faster on the Azure pipelines, virtual machines. It runs fast enough that I can get it to build the complete documentation.
That's great.
Without stalling out, because the Travis run on the complete documentation stalls out. So we wouldn't need to do any of the weird uploading and downloading stuff that we've been messing around. But the thought is that I wouldn't have it build the entire documentation when testing. I would have it run run subsets of the gallery examples and tutorials and make sure they all run, but they don't have to run all at the same time, and like set up blocks of them to run, and then also test the documentation building without generating gallery examples. And then once everything tests, then whenever it like deploys, that would be when we would build the entire documentation. It doesn't have to happen every time.
That sounds very good, because it's annoying. I mean, because we still have that pull request from the Cobalt folks, and yeah.
I don't know what was going on. I've looked at it so many times. Like,
yeah. Okay. Well, we can figure that out, and maybe even just kill the documentation testing for now and fix it later.
Unfortunately, like, we just have to make sure it gets uploaded somewhere else.
Yeah.
Like yeah. Okay.
Cool. Thanks, Joe. Peter, are you familiar with the continuous integration systems that Joe was talking about? We just dropped a lot of jargon. I appreciate that. Oh, you're muted.
I'm unmuted. I'm unmuted. Sorry.
Yeah.
Yeah. No, not at all.
Fair enough.
That's fine. I'm totally happy for things to whiz by me. That's okay. I'll jump
we
in
have
when
we have a suite of tests that get run to double check that everything is functioning the way we think it should function, and they get run in the cloud every time somebody commits to a GitHub or somebody creates a pull request. So just to double check that things are working correctly. And we ask if people contribute new things, that they also contribute tests to run those new things.
Sure, yeah. And how often do you get that from people?
There's a really nice pull request right now on SimPEG that does exactly that. I didn't check in the documentation side of it. I think it was okay. I don't remember that. Oh, the other thing is I was going to remove the Napoleon extension on Discretize because I don't think it was being used, and it was interfering with the NumPy docs. Basically, you weren't able to like create plots within NumPy examples. It just wouldn't plot them no matter what I tried. I'm like, okay. So now instead of having to use when you're writing documentation, you used to have to use that like, plot it command in restructured text or whatever, but now you can just use NumPy examples, like the way the NumPy docs work. If you look at them and you see the triple right arrows and then things going on like that. So it works now.
That would be great, Joe. I think that's probably my fault that was in there as I was trying to figure out how all these different documentation templates work. So sorry.
I'm just like, why is this not working? I can't figure it out.
Fair enough. Dieter, do you have any updates?
I guess so. Little bits everywhere, but all the things I've been working on in the last weeks are sort of slowly trickling into master. So now the survey class is in, and I hope soon that simulation and the optimization, and then finally the command line stuff will be documented and tested enough to be in. They are similar to the SimPEG ones, but probably different enough just because I only have to deal with one case. 3D tensor meshes, right? one method. And that actually brought me up this issue I raised, which I was wondering what you think about it in the Discretize. And I tried to subclass a tensor mesh. I'm getting an issue because I would like to assure if I use a Discretize mesh that it's a 3D mesh, so I don't have to take care of that later. and when I subclass discretize, I also want to add 2-3 things that are specific to my code. But if I do that and then I want to do a plot slice, it fails because in plot slice, it creates from self class a 2D mesh.
Mm.
So I think we should
I
probably,
understand.
I don't know if you should there use a discretized.tensor mesh instead of a self dunder class thing, but I'm not actually sure if that would resolve the problem. But yeah, because I think discretize could be interesting for other folks down the road to subclass as well for their particular use case. So might be something we could think about how to improve that. Yeah, that was this. And what else did I have? No, I just thought, because we talked about on Slack on some point, this issue tackling. Did you talk further about that? If you should might do like monthly paperclip fixes or things, how they call them, the little issues work together on issues and PRs, or I don't know, could be an idea.
Yeah, we didn't talk about that further. I don't know if, what do folks think? And I guess, what do you also think is sort of a reasonable amount of time they could commit? Maybe.
Exactly.
Yeah.
Because many of the things maybe need a small discussion.
Yeah.
I thought when I looked at some issues, I wouldn't want to decide that. So probably maybe it's more an issue now that everybody's working from home and there is no group meeting at UBC. But yeah, it's something you could think about if you should have some regular monthly or so issue tackling. Thought I'd bring that up here.
I'd say yes, for sure. Yeah, it's a good idea, man. It's the best way to get everybody's attention at the same time. I mean, it's going to be hard to schedule, but if we can do it, that'll be great.
Would sort of a first shot of like maybe 2 hours, like a 2-hour meeting once a month, maybe work? Okay.
Yeah. It's probably even more a discussion and then assigning who takes care of it. And then...
Yeah. Okay, well, we can maybe start. Would somebody be willing to start a poll of sorts, and we can try and get something in the next, maybe at the end of the month or early August kind of thing?
Yeah, it doesn't matter to me. Every day is the same.
Fair enough. They all blur together. Cool. Okay. Well, Dieter, would you mind putting together just a little poll for, let's maybe say, the last week of July, first week of August? We can try something in those 2 weeks. And
yep, I'll do that.
Thanks. That'd be great.
And quick question. In EM data, what do you usually use as standard error if you don't have anything better for observed data? Do you use like 5%? Do you use 3%? Do you use 20%? What is
pick a number?
What type of EM data? Is it like FEM or TEM?
FEM, controlled CSEM type.
Okay. Yeah, I mean, a lot of the times we organize the data by absolute value at each frequency, and we look and see this curve, and we sort of pick a floor and a percent based on that curve.
Okay.
So it's actually, I could send you something and it might have a bit of a similar flavor to the off-diagonal components of MT data, and I could kind of show you what I mean, but yeah, usually we plot it up that way, and we take a look at the floor, or we choose a floor and a percent based on that.
Yep, that would be great. Thanks.
Thanks, Dieter. Devin, would you like to go next?
Yeah, I really don't have too much. Dieter was talking to me about having some errors when he tried to import the stuff and work with the EM1D programming that I've been working on. So I need to go in there and clean that up. So I haven't really gotten around to it, so sorry about that, Dieter. But that needs to be done. I have no import errors. Things seem to work fine on my computer, but Dieter's been having some issues. So whatever is set up in those init.py files is not really universally working.
Okay, thanks, Evan. Sagi, do you have any updates?
Nothing
Yeah,
particular related to SimPEG. I answered a couple of questions in the discourse.
Oh, thank you.
Yeah, and I have one question from like I think it's a Italian girl. I'm not sure what's her name. But she was actually trying to do a surface wave inversion, but her simulation code is in MATLAB. And she was trying to generate the problem class in SimPEG to run an inversion, but having a hard time. But yeah, I haven't done the follow-up answer, but that seems like an interesting use case that we are hoping to have a bit more.
Okay, cool. We can take a look at that because that, in theory, should be possible.
Yes, I think it'll be kind of interesting to use like SimPEG's inversion class a little bit more. Mm-hmm. So if you can plug in other simulator and then wrap it up with SimPEG's problem class and then run in the SimPEG's inversion. So that'll be an interesting use case.
Yeah. We should, at some point, Dieter, revive the example that we started with EMPyMod, because that should now actually be hopefully pretty straightforward. And if we have one example of a different forward simulator being plugged into the inversion machinery, then hopefully, an N of 1 can lead to more. So, yeah. Thibaut, do you have any updates?
Not really. Like on the short term, I'm still making my way through merging the simulation class with my own branch. So making slow progress on that. But yeah, I will hopefully I will get something working soon.
Cool. Doug, do you have any updates?
Not so much of an update as sort of a query or something just to kind of throw out. So we're still getting requests for academic licenses for a lot of the UBC codes, and they've been, in particular, the potential fields as well as the like the 1D inversions, and the SimPEG codes are they're mature, they're being used, but when I was looking at the most recent request, I didn't have a really kind of nice kind of consolidated way of saying, hey, you guys have been using the UBC codes, that's great, you're happy to keep providing those, but at the same time, we've been developing a lot of stuff on SimPEG that we've got potential fields, and now we've got better 1D inversion codes than we were previously distributed at UBC. And so why don't you take a look at this? And here's kind of a easy way of focusing on how you can see that. And actually, I kind of looked at just opening up the SimPEG website, and I could see from somebody who's just not sure about anything, like how they would try to make that connection. I have a feeling there's a potential here for raising the visibility of SimPEG just by offering some suggestions, like, okay, if you were used to this, then here's a code that is doing the same kind of thing. It's open source, and here's an example. So it's just a little bit of kind of PR and organization at some top level to kind of help that transition.
That's a great point, Greg. Oh, go ahead, Sagi.
So is that more like directly connected to a specific UBC code? Like let's say, oh, here's like an example of DCIP 2D. Here's an example of SimPEG.
Yeah, so the thing that happens a lot, and again, just happened the other day, when somebody's saying, they've got, they just like to have an academic license, for Grav 3D and Mag 3D and for the frequency domain, time domain EM, right? And sure, so we can provide that, but I think we've gone ahead from that technology, and it's available. And we just kind of need to have something that would point, somebody who's totally unfamiliar with SimPEG, with Python, but just like, okay, well, here's a new resource, and yeah, they've got 3D, gravity inversions or 3D magnetic inversions, and just to kind of bridge that conduit could I think help a lot, because I'm surprised at how many requests we still get for those, for those older codes.
Yeah.
And I think
hear you, yeah.
as time goes on, the whole vision is that, the codes in SimPEG will eventually, make be enhanced versions of anything that was kind of done at UBC, and, everything will somehow be transferred to the open source. And that might be an incremental process as things proceed, but for each time there's a tick in the box for people who've been using a UBC code or other code. Here's a SimPEG code that might do the same kind of thing that you want, and also allow you to interact a bit more.
Maybe it might even be worth, I don't know if it says something on the website, but if it would be saying something like that SimPEG is the successor to UBC, so that if somebody comes across that website, they might realize that it comes from UBC in a way, and it's the new way. But I don't know if everything that was in UBC is now in SimPEG, or if there are still differences.
No, and also SimPEG has got a little bit broader community than just UBC. So I think that, it might be useful to have some, kind of loose connections there, but not make not formalize it too much or make too big a thing out of it. Just that, okay, if you were using, a UBC code, we now have one in SimPEG that is available. In fact, that's kind of what probably, Dom, you're talking about from a Mira perspective as you're talking to clients. Is that correct?
Yeah, that's the thing, right? Is that the people who are asking you for an academic license of UBC, they're end users, they're not programmers, and they're used to just have a exe, maybe an input file, and then just press run button, which we don't have in SimPEG right now. This is sort of what I'm working on with the apps that I'm building on the Mira side. But at the same time, we probably don't want to tie SimPEG too close to a corporation. So we kind of need to have something similar to this to be able to divert people towards SimPEG, just the end users, people who just want to run jobs and just, explore data, not programming. So that I guess that's what we're missing. That's what you don't have to offer, right? You don't have to, here's an inversion.
But the academic licenses are coming from academia, and sure, some of the research is just inverting, inverting the data, but they are also that kind of target group that we might think about from the point of view of actually interacting with code and maybe doing, tailoring it a bit to their, to their research as well as mostly using it. So I think there's another segment in there aside from just some end user who might, just want to buy a commercial code that has an input and output and all the bells and whistles.
Yeah, from my short experience, like obviously I haven't talked to as many people as you did in your career, but I would say that 90% are end users. Very few people are actually interested in the mechanics and seeing it. So most emails that I get on a daily basis are people who just want to process their data. They don't really care about, what solver they're using or whatnot. So, and those end users, they need a visual, they need a way to interact with their data, to be able to, look at the model and everything. So, and this is kind of beyond what SimPEG is there for. It's a bit of a catch-22, right? We want these guys, but we don't want to spend the time taking care of them either. So yeah, it's a bit hard. It's tough. It's a great question.
I think there's, at least for me, what I'm seeing is there's sort of two levels of conversation coming out of this. One is like, you know, communication, and is the website actually answering the questions that a new user would have? It's like, what does SimPEG actually do? And I don't actually know if our website fully answers that, and like, what does it do and how do you get started? Yeah, we should take a critical look and actually see if those things are answered. But the other thing,
isn't that the introductory part of that website? I mean, there was literally a heading that said "Getting Started" and then "Getting Started for Developers."
but if you go to SimPEG.xyz, which is the starting,
fair enough.
That's not what you're going to see. Yeah. And so, yeah, so that's something we should take another critical look at.
Maybe we just need to put a YouTube video together that just, you know, have like a YouTube of UBC users, how to get started, and then just, you know, have a quick video that just show how to go from data to inversion, even if it's within a notebook that has a little bit of code.
That's actually an idea that has merit. Yeah, I could see something like that having a place. Just something simple, something tangible, and that they could kind of connect with without having to, you know, click on too many things and ask too many questions.
Yeah.
Because we have all the loaders, right, for UBC already. We have the mesh, we have the data loader, at least for potential fields and the MDC. So we could, in theory, offer that. It's low cost of us to put together.
Yeah, well, and actually, if we generate notebooks like that, that probably serves dual purpose with the SEG workshop, is we just reuse them and, you know, provide novel audio. I think the other thing that this brings up, and I know it's something we've talked a bit about, but it might be timely to start thinking through this, because I think it feeds into where we need to refactor next, is actually thinking about a command line interface for SimPEG. And what does that look like? Because for a lot of people, that's just like how they run codes. And it's not a hard thing to do with Python. I think the hard part is like, how do we design an appropriate input file and sort of those wrappers? And I know like each of the modules right now has their own flavor of wrappers that are actually very unique. Like the IODC is a wrapper. I know, Dom, you've done the potential field wrappers. And those have enabled other people to get up and running, but they're like, we don't actually sort of have an opinionated approach to this right now that's kind of uniform across SimPEG. So it might be, I mean, it might be easiest to start there with the forward simulations, because I feel like the forward simulations we're now reasonably happy with the structure. I think the inversion and the optimization classes need a bit of work, but that said, some of the like wrapping is probably independent of like what we fix under the hood. So yeah, it might be worth kind of thinking about how do we define a command line interface for SimPEG forward simulations.
I agree there, and I think many companies, if they use it, they will run it like this on servers at some point. What I would suggest is, if at the very moment you start with that, also start with logging. So implement logging from the start, because I think it becomes very important with the logging module or another Python package to store all that stuff. But yeah, I agree that the terminal-based stuff is very easy with Python, but define how you do it, because then it's also, I feel like it's even harder to change afterwards than Python code, because people make that and install it on the server for long-term stuff. So you really not want to piss them off by changing all the time your stuff. So yeah.
Yeah, that's a good point. Cool. Thanks, Doug. That's a really good point. I guess I can give a couple of quick updates before we're on the hour. I've been working on, against a little bit of the stuff with the paper with Dieter, so doing some EM modeling. And I actually decided to get up and running on Google Compute Engine. Just mostly I wanted to play with it and see how challenging that was, but also they've got high memory nodes and not having to deal with, you know, HPC centers and me stealing too much memory. It was actually pretty easy. And so if anyone wants to play around with Google, and if you need any tips or things like that. So what I ended up doing is I was able to install sort of the SimPEG stack and get a Jupyter notebook running. And then you can actually basically attach like your browser to a persistent IP address that is basically your machine. And if you sign up with a new account, you get $300 of compute credits, which if you're just running moderate sized examples will actually go pretty far. So been playing around with that, which has been kind of fun. And that is probably about all that I do.
How's the costing is working, Lindsay? Is that I was actually I got $1,000 credit. I applied that research something like
yeah.
You just need to write a paragraph to ask for. And I was actually curious, like I haven't tried yet, but I was curious like how their costing works. So is that like once you turn on your SSH kernel, I think it seems like they start to charge. Is that how it works? Or like, so I think if you just turn on and don't do anything, they still charge.
Yes, so you can turn it off. I mean, it depends on what kind of node you get. But yes, if you do sort of the standard virtual machine, as soon as you turn it on, you're paying for it because you've basically reserved that machine and nobody else can use it. But you can turn it off. Like if you, for example, if I'm working on this and I'm not going to be working on it tomorrow, I can turn off that machine and my data is still there. Like I still paid for storage, and then I can turn it back on the next day and get up and running again. And so the storage fees are decoupled from the compute fees, and the storage fees, as long as you're not generating terabytes of data, is pretty minimal. So for example, I had it running basically all day yesterday, and I think it was like on a reasonably high memory node, and it was like, I don't know, $6 or $7 for the whole day. So
that's actually not bad.
Yeah.
But that's a single node.
Yeah, that's actually
high memory.
Single node high memory. And I think it has 8 CPUs or something like that. So, but the costing structure, I can send you a website that they do a pretty good job breaking down the pricing. So.
Yeah, that's not bad at all. $8 a day.
Yeah.
For on demand. That's pretty good.
Yeah. It's you.
It's the price of a laptop a year. $3,000.
I know. So.
But I think once you're like thinking about running a little bit large code, it's actually goes up pretty quickly. So say you got 100, you need 100 nodes, then it's like $100, like $600, $700 per day. Well, maybe it depends. So I'm not sure. It's expensive.
You get you hooked. It's like crack.
Yeah. Perfect. Well, that's all I've got. Does anyone else have questions or thoughts before we wrap up for the day?
That's it for me. I think I need to get Nega going soon. Have a good day, everyone.
All right. Thanks, everyone. We'll see you
next week.
Thanks for coming. Good seeing you. And yeah, we'll hope to see a lot more of you.
Yeah, I hope so. Yeah, I hope we can just keep moving forward. Sounds good. Nice to see you.
Cheers, guys.
See you, everyone.
Bye.